The back of your assessment for exponents and exponential functions starts off with exponential functions. So keep in mind that the exponential function form is a times b to the x. A is your initial value, also known as your starting point. Could also be known as that y-intercept. B is the growth or decay factor, not the rate, but the factor. So, if we buy a home for $180,000, that would be worth $180,000 at the start of owning the home. If it increases at a rate of 3%, well, initially we had 100% of our value. It's going to increase by 3%, and so we will end up with 103% worth of our value. If you change that to a decimal, because you want to do that before you plug it into B, take your decimal, move it 2 places to the left, and you end up with 1.03 to the x. Now this wants to know the home after 10 years. So if I plug 10 in here for the x, I will know exactly, well, approximately really, how much this home is going to be worth after 10 years. So we have $180,000 initially. Need one more zero on there. Times, so I'm going to put parentheses, 100% of our value and 3% more. And I want to know what it's going to be in 10 years. So it looks like it's worth $241,904-ish, which is approximately $242,000. This is the most important part right here. Making sure you change it from rate to factor. Number 8, Doug purchased land for $8,000, so our initial value is $8,000 in 1995. Now 1995 is going to represent year 0, because that's our start. I'm going to put a 0 right here. And then it's going to depreciate, so it's going to go down. We want to know 2002. So we have 96, 97, 98, 99, 0, 0, 0, 1. So we have 1, 2, 3, 4, 5, 6, 7. And you can always double check it. Oops. 2002 minus 1999, 95. Yep, 7 years later. This is going to be important to change your initial years to 0 and then count it out to your next, what it is you're trying to predict. So it starts off with $8,000. It's going to depreciate, meaning it's going to go down. So starting at 100%, it's going to go down 4%, meaning we will end up with 96%. If you change that to a decimal, it's 0.96. And then we can plug in our x, which in this case is 7 years down the road. So you have 8,000 times 0.96 to the 7th year. 6,011 approximately, so C. We want to know which is not true. So what I'm going to do is I'm going to label these true and false. We got a coffee company opening up stores. X is the number of years since 1992. So this is in years. And then this is the number of stores we open. So the coffee company had opened 400 stores by the end of 1992. So if this is years since 1992, the end of 1992 would be in here. So yeah, it's about 400. So this would be true. The coffee company opened 100 stores in 1 year. Well, let's see, from year 0 to year 1 is right in the middle, and that is 400 to 500. He did open 100 stores in 1 year. Maybe not every year, but in 1 year he did. So this one is also true. Every year the number of stores the coffee company opened increased 25%. So this is a maybe because I do know that exponential functions often grow at a percentage rate. Since 1992, the coffee company has opened 250 stores each year. This is linear. If you do the same exact thing every time, 250 this year, 250 next year, 250 next year, that would be a linear function. So this is definitely false. So I'm going to circle that one. That would not represent an exponential function. 10. It's talking about a graph, so why don't we graph this? Put it in your y equals. So you have 1/3 times 2/3, and then the x goes on the outside. Let's look at the graph. So the first option talks about the asymptote. The asymptote is down here. That's the line that it's not going to cross, y equals 0. This says the graph has a vertical asymptote. That would be up and down. I have a horizontal asymptote. So this is false. The graph crosses the y-axis at 0.29. Most definitely not. If I wanted to check it, I can look at the table. No, it crosses at 1/3. So this is false. The graph has an asymptote at y equals 1/3. No, it goes below the 1/3. And it continues to go smaller and smaller and smaller and smaller and smaller and smaller and smaller, but never 0. So this would be false. The graph decreases from left to right. Yes, it does. It decays. So that would have to be true. A student used this function to show how the balance in a savings account will increase over time. What does the $5 represent? $5 is the amount the student first put in. And I'll put into the savings account. You can also put it's the initial amount the student put in. Make sure you don't leave it at initial amount or starting point because those are very generic. You want your description to be specific to the problem. 12. We also want to know a true or false here. The range is less than 0. Well, here's my 0. That would be under. So that's false. The domain is all real numbers greater than 4. Here's 4 for domain, and that would mean it would only go right. But it doesn't. It also goes left. So this is false. The range is everything bigger than 0. Sure enough, it's all above the 0. The domain is less than 4. That would mean it only went left, and you might think it does, but it actually continues on over here, getting smaller and smaller and smaller and smaller and smaller and smaller. So that's false. So C. Make sure when you're making your corrections that you're writing a sentence about the error that you made. It could be something about vocabulary, it could be mathematical, it could be a misunderstanding, but in order to get some of this credit back, you're going to need to write down a sentence.